In this video, we will talk about representation of a sparse matrix, and also we will see how to display a sparse matrix from that representation. This topic we have already studied in arrays. Now again we are learning it in linked list. I have an example of a sparse matrix of size 5 cross 6, that is 5 rows and 6 columns. A lot of elements are zeros, only few elements are non-zeros. 8, 7, 5, 9, 3 and 6 and 4. Just 7 elements are non-zero. Now how to represent this? So for representing a sparse matrix, we want to avoid storing zeros. We want to store only non-zero elements. For example, if I take this element, this is non-zero. So for representing it, we should know what is that element, and also we should know where it is in the matrix. So for that, I should know the row number and column number. So 0, 4 is 8, and this 7 is 1, 3. First row, third column, value is 7. So for every non-zero term, we should know row number and column number, and then the non-zero term. So we have to represent this one such that we should be able to regenerate the same sparse matrix. So let us see how we can represent this one by just taking non-zero elements. So I will draw the structure and show you. For representation, I have taken an array of size 5. This array is representing rows. There are 5 rows. So the indices in an array represents row number. Now for representing non-zero element, like example 8, I need to know column number and the element itself. So column number is 4 and the element is 8. So that I will represent it as a node. Fourth column, element is 8 and this is null. So this is a node containing column number and the non-zero element. Then next row, row 1, there is one non-zero element at column 3. So here we have a non-zero element at column 3. So column 3 element is 7 and this is null. Then in row 2, we have two non-zero elements at index 0 and 4. 0, the value is 5, and next at column 4, value is 9. The next row, we have an element at column 5. Then in this row, we have two non-zero elements at column 0 and column 3. So this is the structure. So this is a linked list. This is another linked list. This is another linked list. So all these are linked lists. So it's an array of linked lists, and the name of this array, if suppose it is A, then this is also A. We can call it as A is an array of linked list. Now how we can form this structure? This structure is having collection of linked lists. So linked list is a collection of node. So the node structure, this contains what? Each node contains column number and non-zero element. So if I define a node structure contains three things: column number and the value and next pointer. So using C language, if I define a structure, this is structure node will contain three elements. One is column number and value and a next pointer. This is a node, this is a structure. Now how to create this structure? For creating this structure, I need an array of number of rows size. If this is m cross n, then I should have an array of size m. So let me create this array of size m. So array is of type node pointers A of size m. So this is an array of pointers of size m, whatever the size is. So this will be an array. Then at each location, let us say A of 0, assign this new node. So I am just assigning just one node. Like this, I have to create all these linked lists. So you can write a program, you can write a procedure for creating this type of structure. I have just given the idea here how we have to create this one. Create an array of pointers, then at each location create a linked list of non-zero elements. So you can write a program that is taking input from the keyboard and asking what are the non-zero elements. From keyboard, you can take row number, column number and the non-zero element. So for a given row number in that particular row, that is in that particular index, you can create a node having column number and the non-zero element, and you can form a linked list. So this is a student exercise for creating a sparse matrix, adding two sparse matrices or displaying sparse matrix. These are the things that you have to do. So I'll just list out. So these are the three things you have to do: create sparse matrices, so then you should be able to create more than one, then display, how to display the sparse matrix, and how to add two sparse matrices. Out of this, I will just share the idea how to display this one. So I will write on the piece of code for displaying this sparse matrix. Let us see how to display. So for displaying, I should display all these rows. So for all these rows, for I assign 0, I is less than m rows are there, I plus plus. This loop will cover all the rows. Now in each row, what I should do, I have to scan through a linked list. Let us take this example, it is having more than one node. So scan through this one. So take a pointer at the beginning. So I need a pointer. So let us take a pointer P. Let us take a pointer P. For example, I am showing it here for this linked list, right? Pointing here so that I can get it from A of I. So at A of I. So P is pointing here. Okay, let me show it here. This is outside. So we have to do it for all. But here you can see it. So I am showing it here. So for displaying all the elements in a column, I should repeat it for n times. So I want to display zeros also. So for that, take one more for loop for j assign 0, j is less than n and j plus plus. So this will repeat for total n times, that is equal to number of columns. Then at each column, I should see that if that is non-zero or zero element. So if it is non-zero, I should print the element. If it is not, I should print 0. So how I can know is it non-zero or not? So this P is pointing upon some node that will show me. So the column number. So here what I should do is, if J is matching with the column number, so that is P is a column, P is a column, this is column. If it is matching with P's column, then print the data here, non-zero element. So print the value, non-zero value, and also move P to next node. So printing the value and moving P to next node. This I have to do if this is true, if the column number is matching. If it is not matching, else I should print 0. Else print 0. That's all. This is simple. So I will trace this one little bit. Just watch it. I is starting from 0. So I is here. Then P assign A of I. So P will be pointing here. First one. Then for j assign 0 to n. 0 to n means 0 to 5 it will go. J will repeat from 0 to less than n. So 0 to less than 6, that is 5. So it will go up to 5. Then what it is doing? First time j is 0. Yes, j is 0. So is it matching with P's column? Is it matching with P's column? No, it is 4. So print 0. 0 is printed. Then next j plus plus, j becomes 1. Then check if j is equals to P's column. J is 1. Is it equal to P's column? No. Print 0. Then j becomes 2. J plus plus. Then j is equal to P's column. P's column is 4. So up to 4 it will not be matching. So it's not matching. Then print 0. Then j becomes 3. Print 0. J becomes 4. It's matching now. So print 8. And move to next node. So P will move to next node and P became null. P became null. Then next, this becomes 5. Is it matching? No. Print 0. So that's how it will print all these things. That's how it can be displayed. So I have just given the idea how to display this sparse matrix. Complete matrix 0, 0, 0, 8, 0. All the values are printed. Zeros as well as non-zeros. So rest of the thing is an exercise for you. Write a complete program and also write a program for adding two sparse matrices.